Hello. Today I'd like to carry on the seminar of 2020. The first learner of our seminar presentation is John Ho-hee of my lab. Actually, I asked you guys that presentate what is your skill, what you gonna learn, the skills for your project. So maybe you can explain your own project, but I want to explain more about the method, how hard the method is, what is the procedure of the method, and what is the technique or hidden technique or some kind of know-how to do successfully using the method. So I will explain more about this part after Ho-hee's presentation. So please submit your presentation before the Sunday. So because I have to make this video to upload to YouTube, so you guys have to send the video to me at least until Saturday, okay? So I will start Ho-hee's presentation.
Good evening, Professor and my classmates. I'm Ho-hee John, studying bioinformatics in the plant genomics lab. What I'm going to talk about today is about what to learn in the lab and what skills to learn. First, I will briefly explain what kind of research our lab is doing, and then explain what I have been doing so far. And I will tell you about plans and research directions. Unlike other labs, our lab mainly analyzes data rather than experiments. Rather than creating data in the lab itself, we have been using various data and analyzing data from different labs and co-work to obtain data from outside, such as NCBI, or creating a database using data. Not only Arabica fish, but also soybean and dog wheat have been analyzed, and medical data are currently being analyzed. Being able to work with multiple fish without being confined to plants is one of the strengths of our lab. Of course, we do pipette, but we request the sequencing through simple experiments such as DNA extraction and RNA extraction. In these environments, I have been promoting analytical techniques rather than experimental skill. Because it is important to create our data by experimenting it yourself, but it's also important to understand how to process the already created data and show it intuitively. This is why I came to this lab. Today, as NGS grows, countless data are being created. So now, I think it is more important to visualize the data rather than how much data it has. Data makes sense when it is presented to others. For this reason, I have been collecting and analyzing data for the past 2 years, creating my database and visualizing it on a web page. I download expression level data related to the stress of Arabidopsis in NCBI and processed it into an analyzed program called Callisto. Later, I created a web page using a web application library called Django. and visualized it using a tool called D3. So the skills I will be running in this lab are computation skills and biological knowledge. I think it is competitive enough because there's still a storage of bioinformaticians who are good at these two technologies. The computation skill is largely divided into front end and back end. The back end is work to store and manage data, although it is invisible, such as database production and web page construction. The front end is the design of the user interface. It's the parts that is displayed. By connecting the front end and back end, a site like NCBI is created. Therefore, it is important to link two fields as well. To cultivate my abilities in these fields, I'm trying to become proficient in Python, the computer language I have used so far, and JavaScript used for visualizations. Python is not a language created or above for bioinformaticians, but it is a language. It is a language that is used a lot because it is easier and more intuitive than other languages. I have been using Python so far, but there are still a lot of missing parts and lots of things to learn. So this part is given priority. Next is web application development. All the created data is stored in a database. I think the value of having the same data varies depending on how the data is loaded or how it is visualized. Therefore, we plan to make an application so that data that can only be used in the PC can be used on mobile. Also, I would like to study JavaScript used for visualizations more and provide easier and more intuitive data in various ways, such as Venn diagram, graph, and table. And I think biological knowledge is basic, but necessary to be competitive when compared to other developers. It is difficult to get a job with the currently development alone. I need something different to stay ahead of others, and I plan to fill it with biological knowledge. I think this part can be improved by taking classes from other professors or through co-work. Finally, my goal is to create a mobile application to study in an environment that is not constrained by space, and to make research more efficient by using intuitively recognizable visualizations rather than text and numeric data. This is my presentation over, and thank you for your attention. 감사합니다.
Okay, thank you for your presentation. I think he performed really good. He explained why he started bioinformatics as his career, and he believed the bioinformatics is most important for this field, and he can learn the other biological knowledge from other professors or lectures. So, is there any questions or comments, or maybe you have a different opinion from his let's say from his talk? Then please comment. Okay, hold on. Please comment your opinion in the comment section. Okay, so okay, let me go to seminar. Okay, go to 자료실, and I will upload this video at number 4. Then you guys have to leave a comment or questions. So maybe, so for the attendance check, you just say thank you, or I watch it, or nice introduction or something. But these greetings is for attendance, right? But if you give him a question, good question, on this comment section, then I will give you an additional, how to say, score for the participation of this seminar. Okay, so this is how I want to drag more attention to this seminar. Actually, I don't like this attendance check. All right. So who is next? So April 7th, 이지현 and 최성훈, right? So let's go to seminar section, and I will check 이지현's abstract. Actually, I read this abstract, and she is explaining what is the plant immunity and what is the purpose of the research and what is the goal of the research, because the plant immunity will play important role in the future life science market and so on. And the most importantly, to study BRA, I need to find protein that interact with BRA through library screening. So I want you explain what is library screening and how do you screen the libraries and what kind of library you are using, and check the interaction strength through is2 hybrid and explain how do you do the is2 hybrid and maybe biopsy, right? So maybe it is okay to use this presentation form, or if you are okay, I think it is okay that you can just record how you the pipette, right? How you do the experiment. And for the other side, the dry lab side, maybe it is okay how you code. You can record your own, I say, the screen you are coding, right? So feel free to do it creatively, okay? Creatively, okay? So I don't limit you in this PPT. So maybe you can use some kind of form that you are interviewing somebody. Maybe you are interviewing the other guys who is doing experiment, and you can ask him, so what is this and what is that? Why are you doing in this way? Why are you doing in that way? And please explain what is the trick, hidden trick of this experiment, and what is the final goal of this experiment, or if you learn this experiment, then how you become more, let's say, important in this field, and so on. Okay, so this is how you do the make your presentation or your video. Okay, so thank you for watching. So see you next week.